Alright, so we're going to look here at expressing large numbers or very small numbers in using scientific notation. So looking at question 1, it says, what is 12,325 written in scientific notation? For scientific notation, it's got to be a number between 1 and 10. So to make this a number between 1 and 10, my decimal is going to move to here. Now originally it's right there behind the 5. So to move it from here to there, how many times I move it determines my exponent. So something I forgot to do is right here. That's not a number between 1 and 10. I'm not going to pick that at all. It's going to be one of these others. I'm also not going to pick this one because that's a negative exponent, which means I would have a really small number and I don't. So that's not that one. So to move the decimal from here to here, it's moved 4 spaces. So for that reason, I'm going to pick C. Number 2, what is this number written in scientific notation? So I'm looking at these and I'm saying, I'm not going to pick this guy because it's not a number between 1 and 10. Looking at the rest, because it is a decimal, I'm not going to pick a positive exponent because that would suggest it should be a really large number. So I'm looking between B and C. How many times am I going to move this decimal from here to here? Tells me my exponent number because it's going to be between 5 and the zeros to the right of it. That makes it a number between 1 and 10. So to move it there, moved it 3 spots. So that tells me my exponent's -3. What is this number written in standard form in scientific notation? So I'm going the other direction. This tells me how many times I'm going to move that decimal. So right here, this is 1, 2, 3, 4, and I'm out of digits here, so I'm going to put a 0 for the 5th time I move that decimal. I'm going to put a 0 for the 6th time I move that decimal. So I'm looking for something that matches that. Now I'm not going to pick decimal because my exponent was a positive, so I know it's going to be a big number, not a decimal. So it's one of these two, A or B. Between the two, the one that matches is this one right here. This one did not move its decimal enough. What is this number written in scientific notation, or excuse me, in standard notation? So the negative tells me it's going to be a small number. So I'm going to get rid of D for that reason. The 3 tells me I'm going to move that decimal 3 times. So I've got 9 and 2 and 5 and 6 and 8. I'm going to take the decimal from here. There's once, twice, 3 times. Put the decimal, you can put a 0 for the ones place, and the number that matches that would be this one. Negative exponent, so it's a small number, not A, not B. So I'm looking between C and D. 7 is the number of times that I move the decimal. So the 3 and 0 and 5 are not part of that count. But the 8 is 1, 2, 3, 4, 5, 6, 7. Decimal, a 0 for the ones place value. And the one that matches this is D. So you count all those zeros, there's 6 zeros there, that matches D. Which of the following statements are true? This is where you're going to use your calculator. When you do, the ones that you will find to be true are A, D, and E. Circle each measurement that is equal to 0.0043 liters. The easy part is right here, matching liters to liters, just move that decimal. So the one that you're going to pick is this one. Now what makes it a little more challenging on the right side is we're talking about milliliters. So how many milliliters will be equal to that? That would be this one. All right, and moving up to 8, 9, 10, 11, and 12. This one will be C. Move the decimal there. So that's moving it 3 times, so that's C. Here, moving it, there's 3, 4, 5, 6, and it's a negative 6 because it's a decimal. It's a really small number. Here, we're going to be moving that 6 times. It's a positive 6 because it's a big number. Here, it's going to be a positive 5 to move that decimal for that big number. Oh my goodness. I'm going to count all these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So from here to here, I moved that decimal 11 times to get it in between that 3 and that 7, and it's a negative 11 because this is a very small decimal. So that one matches F. Scrolling on up to number 13, write 32.6 million in scientific notation. Well, first, let's write it in standard form because some of us struggle with that. So there's 32 million. Here's what follows. So that's 600,000. Now to put that in scientific notation, I'm going to move the decimal from here to there. This will be 3.26 times 10 to the, moved it 7 times, that decimal. On this one, number 14, you're going to take this one and divide it by that one because it says how many times greater. So it's 5 times 10 to the 15th divided by 2 times 10 to the 12th. So this part is equal to 2.5. This part, 10 to the 15th divided by 10 to the 12th, that's really hard to read there with that pen. So that is 10 to the 3rd. If this were a choose all situation, you would want to watch out also for 2500. That's equal to that. When it's asking for which is greater, this one or this one, when I put this in scientific notation, this is 5.7652 times 10 to the negative 7. So when you compare that with 5.764 times 10 to the negative 7th, so same exponent, that matters. The number that's actually bigger is this one. Okay, keep in mind they did have the same exponent there. Alright, and this is where calculator skills come in. I'm going to show you some test taking strategies here, right here. A, it's not going to be it, that's not in scientific notation. When you actually do this on the calculator, you're going to get this one right here. So the biggest thing I have to say about this is use your parentheses on your calculator so you actually get the right thing. Here, 73 thousandths minus 5 1/10 times 10 to the negative third. Also, watch out. Make sure it is in scientific notation. That one is not, so don't pick that one. When you're done, you're going to pick that one on your calculator. Again, make sure you use the parentheses around the scientific notation expression. Here, looking for not scientific notation so we can get rid of it. Those two are not in scientific notation, so don't pick those. When you do it in your calculator and push enter, you're going to pick that one. Alright, again, not in scientific notation. Don't pick it. The answer for this is A. Make sure to get the right answer that you put parentheses around that. The calculator, not the ones that we use, sometimes we'll use instead of 10 to the 6th power, they will say E6, which means exponent 6, I believe. So if you ever see that, and you probably will at some point, just know that that's what it means. It means a base of 10 exponent of whatever number follows. So when you put this in the calculator, you get what you get. You're going to pick this one for number 5. Number 6, this is a pick all. It says identify, make sure you read all those words, all, and it's not emphasized for you. And when you put this in, again, put parentheses, particularly around the exponent or the scientific notation expression. So the ones that apply, you're going to pick B, D, and F. Those are all the same. Number 7 is similar. It says identify all. So you're going to pick A, C, and E. So that's calculator skills. Here, this one matches this one. This one is going to match that one. This one matches that one. This one matches that one. This last one you actually had to do a wee bit of work there. This one, we've moved that decimal how many times to go from the end, this one right here, to in between the 9 and the 8. Goes with that one. You moved it 8 times, not 9 times. Alright, keep scrolling down. So we've got some extra practice problems here that we're going to focus on, and we're going to skip the exponent properties for now and focus on scientific notation for the purpose of this video. So reading, according to the U.S. Census Bureau as of April 1st, 2000, the population of the U.S. was 3 times 10 to the 8th. The population of Vermont was about 6 times 10 to the 5th. the population of the U.S. was how many times? So that should tell you the operation you're going to do when the question mark is how many times. That's a divide. So we should have on our calculator 3 times 10 to the 8th divided by 6 times 10 to the 5th. So 500 there. Scroll to the next one. Gwen multiplied this by that. Which expression is in scientific notation? Well, look for not. Not. A is not a number between 1 and 10. Not it. D is not a number between 1 and 10. The other thing that I have to say is this number is positive and this number is positive. And never ever will you get a negative if you multiply a positive by a positive. So I'm going to go out on a limb here and say that it's probably C. But I'm going to put it in my calculator just to make sure. So 2.6 times 10 to the negative 5th times, how many zeros there? 1, 2, 3, 4, 5. So when I do put that in my calculator, I do get this, where my exponent has a negative, but my number in front, my big factor in front, that does not have a negative. So that one is C. Next, in a biology experiment, 4 groups of flies were fed different fruits. At the end of the experiment, the average lengths of the fruit flies were recorded. Which statements are true? Group 2 is 20 times larger than group 1. Okay, so divide group 2 by group 1. That's how you're going to find that. So group 2 divided by group 1. So 2, and because that's a decimal 0, you don't need to write that in on your calculator. So 2 times 10 to the negative 3rd divided by, make sure you're putting your parentheses, group 1, 1 times 10 to the negative 4, close your parentheses. I got 20 times, so that looks like a check mark to me. Group 2 is 400 times smaller than group 4. So I'm going to divide group 4 by group 2 and see if I get 400. And if I do, I'm going to pick it. And if I don't, then I'm not. So parentheses 8 times 10 to the negative 5th, close parentheses, divided by group 2, parentheses 2 times 10 to the negative 3rd. Okay. Here I got 400ths. Sorry, 400ths. So that's not something I'm going to pick. Group 4 is 20 times larger than group 3. So 4 divided by 3 again. Or group 4 divided by another group. So I'm going to change what I've got in my calculator. See if it comes out to give me 20. So it does work for that one when I divide group 4 by group 3. Alright, 3 is 500 times smaller than group 2. So I'm going to take group 3, multiply it by 500 and see if I get group 2. So 4 times 10 to the negative 6 times 500. So that one worked out. Group 1 is 80 times larger than group 4. So if I do group 1 divided by group 4. Will I get what I'm looking for? Well, I get 80. 1 times 10 to the negative 4 divided by, in parentheses, 8 times 10 to the negative 5th. I did not get 80, so I'm not going to pick that one. And that was a lot of time on that one problem. All right, make it scientific notation. Real quick, we're going to get rid of positive exponents because this is a decimal. I need negative exponents. Now, how many times do I move the decimal to get there? That's going to be a negative 6. Much faster. All right, still just looking for scientific notation problems. So we've got dust particles and electrons and their masses. Approximately how many electrons have the same mass as one dust particle? Well, that's an interesting question. 7.5 in parentheses times 10 to the negative 10 and close that parentheses divided by 9 point, oh, I gotta put my parentheses in, 9.1 times 10 to the negative 31, close those parentheses. Okay, so on my calculator I have on my display, so I took this number and divided it by that number, put it in my calculator with parentheses around those. Here's what I have on my display: 8 decimal 2 4 1 7 5 8 2 4 2 times 10 to the 20th. For that reason, I would pick that one. Okay, see this? They put the parentheses in there for you. Go for it. So parentheses, 4 and 5/10 times 10 to the second, close it, plus new set of parentheses, 6 times 10 to the third. So I got this 6 4 5 0, 6,450. But it wants it in scientific notation. Now you could look at it and say this is the only one that has 6 and 4 and 5. To move it from here to there, because the decimal starts here. That's where the decimal starts. But when I move it to make it a number between 1 and 10, I've moved it 3 times. It's for a big number, and there you go. And I think that's all I had picked out for scientific notation. I have other problems, but I think that's plenty for now. Hopefully this gives you a good enough understanding. And that's all I have for right now. Thanks for listening.